Infinite Series, Video 5. Back in Video 2, we showed that this particular series converges to 1. Here's a nice little picture of a telescope. You can make that telescope nice and long, or you can compact it down where things will cancel out. That's the motivation for this topic, telescoping series. Alrighty, so again, we want to take a look at this guy and show that it is a telescoping series as an alternate way of arriving at its limit. Okay, we're going to begin with recalling back on partial fractions. We can take this rational expression and break it up as a partial fraction. You can easily verify that. To make a common denominator, you'd need a new numerator, n plus 1, and this guy would need a numerator of n, and then n and n would cancel, leaving you with a 1 in the numerator. Good. So, if we look at partial sums, let's start off with s sub 1. 1 over 1 is 1, and 1 over 1 plus 1 is 1/2. All right. The next partial sum is the very first partial sum, and then add in the next term. Well, it's 1 over the index minus 1 over the index plus 1. And here's that telescoping action. We get a nice cancellation. So we see that we started with 1 minus 1 over the index plus 1, and that repeats 1 minus 1 over the index plus 1. Go on to S3. S3 is S2 plus the next term. The next term is 1 over the index minus 1 over the index plus 1. Again, telescoping action of cancellation leaves us with S3 being 1 minus 1 over the index plus 1. Carry that forward into the nth partial sum as taking the expression of 1 minus 1 over the, nice typo there, index plus 1, and the term 1 over n plus 1 will tend towards 0, and 1 plus 0 is 1 as the index, capital N, goes to infinity. Hence, by viewing this series as a telescoping series where terms will cancel, we're able to find its limit in an elementary fashion. Excellent.